Brilliant. Cheers, James. All the best.
Cheers, mate. So yeah, firstly, thanks of all for Steve for organising this, as everyone else has said, really. So it's quite rare that you get to present to nearly 1,000 people still dressed in your dressing gown. So that's quite a nice bonus as well. I guess today I just want to talk a bit about one of the recent commentary papers that we published in SciMed and Football, which talks a bit about how to use GPS devices in the football codes. Just before I get stuck into the talk itself, I just want to give a little bit of a background about myself and kind of my perspective with GPS as well. So I started using GPS probably about 10 years ago now, as you can see on this picture from that great haircut. So this was at Everton when I was an intern back under Steve Tashin and Dave Billows. And, you know, this was probably, you know, GPS was around at that time, but one of the first clubs to really help push it on, along with clubs like guys like Jamie Harley at Newcastle at the time. So, you know, this was quite a nice insight, and particularly with Steve as well, Steve Tash, to actually learn about the technology and what it does. Then moved over across the park to Liverpool Football Club and spent 3 years there as a PhD student. So as you can see on the picture, I worked alongside Darren Burgess, who gave a nice talk earlier today, and also the likes of Jordan Milsom as well, who's there as well, who's now at Rangers. So learned a lot from these guys, you know, with Burjo, as you've seen from his many Excel spreadsheets that he's got, and also from Jordan as well from a rehab perspective. So, you know, really good good knowledge base that was created there. We used quite a lot of different systems as well during that time, and obviously working with elite players was a great insight to that. We did have some success as well, as you can see on the picture, with that nice 10-handle cup. Not quite the European Cup like last year, but we had at least a little bit of success. I then moved on to Catapult. So with that in mind, it was a little bit different because it was the other side of the fence, really. So obviously more of a commercial job, where for this talk in particular was quite useful because I got a bit more of an insight into the ins and outs of GPS and working with the coders, the engineers as well, and actually got a bit more of a technical grasp for the equipment as well. And then finally, this is kind of where I'm at now. So, you know, in the lecture room with students and bore them to death talking about GPS, satellites and HDOP and all that crap. So, you know, pretty much come full circle. Very much a researcher now, but also still got hands in the applied sense. But just to highlight before I start waffling on, you know, that's the kind of different perspectives I've got going into this talk on GPS. So the first thing really is, I guess, why Infinity and Beyond? You know, what the hell has it got to do with Buzz Lightyear? So these days it seems to be pretty hipster to give your research papers a bit of a funky title to keep people interested. So initially I was just trying to think of something where you actually had a link between, you know, space, GPS and something going on. And I just so happened to be watching a bit of Toy Story at the time. So that's essentially how it first came about. But actually it had a bit of a deeper line meaning on top of that, really. So obviously Buzz Lightyear's sort of famous quote is "to infinity and beyond," which is the name of the paper. If we look at the definition for that, it kind of outlines it as something without limits or something that's limitless in terms of possibility. And I actually, you know, from speaking to many people, many practitioners, I do feel as though that can be the case sometimes with GPS. We do feel as though, you know, it can pretty much do everything. You know, it's a one fits all sort of approach. You know, there's probably people out there who think you can probably evaluate coronavirus load at this point and things like that. So, you know, for me, it's not. It's certainly got its limitations. It is just an external load indicator that we can use. And to steal a bit of a phrase from Chris Barnes, it's essentially just another tool in our toolbox that we can use with our players. So for me, it's a bit of one of those. It can be useful, but I think we need to highlight as well those limitations that we've got. So what that led to then was this paper being published earlier this year. So we had some nice collaborations going on with the likes of Steve, Chris Barnes there, who's going to talk later today, and also Professor Craig Twist and Professor Barry Just as well. So we've been working on this for about probably best part of nearly 18 months in various ways. And I guess just wanted to provide a nice, concise piece for researchers and practitioners to actually use GPS devices day to day. So going into the talk a bit more then, so there's four things that I want to get across really. So the first thing is just looking at GPS data in terms of that signal, noise, reliability and validity stuff. I'm not going to go to town on that because I know that Matt Farley spoke a bit on that this morning as well. The second point, talk a bit about GPS data handling and how we can actually look at some of that data. The third point is our actual interpretation and how we relate that to the sciences as well. And the last point there is then probably the major point is how we then translate that to our key stakeholders as well. So the first bit then just talking a bit about GPS data in terms of signal and noise. As we know, GPS connects the satellites in the sky, as you can see on that picture there, translates it down similar to what you have in your car and gives you so many metrics now, it's unbelievable. Most systems have around about 200 to 300 metrics that you could potentially look at and the different variants of those as well. Just to highlight, first of all though, I guess this concept of signal versus noise. So, like I say, when I worked for Catapult going around, I was based in Europe and managed to travel around quite a lot, this before Brexit obviously, and able to see what a lot of practitioners were doing. And, those who I guess were the more sort of early adopters of the technology would typically just look at the values for face value of what it is, not really apply any sort of stats to it, just typically look at distances covered one day versus the next or between players. Those are a bit more the mature clients, as you used to call them, would probably incorporate some of that stuff and actually also factor in the noise of the measurement as well. Just to highlight that on this slide though, so you can see in the example, we've got maybe two metrics there, or the same metric, two devices. And what we've got is maybe if you've got the top one there, which got a lot of noise around it versus the second one, which has got a much tighter amount of error, you can see that if you've got a change in your data with that red arrow there, obviously that first example, that actual signal or that change is incorporated in the noise. So you might have seen a change in, from A to B, but with that noise element being covering that part of it, it's then hard to interpret that as a true change in your data. If you look at the second example though, where the signal actually outweighs the noise of the actual measurement, we can then see that effectively we're a bit more confident then that our change has been a true change in the data. And I'm not going to go into the calculations of that today. There's a lot of stuff from Will Hopkins online that people can look at. But for me, this is one of the fundamentals, is that if we're not doing this first stage to look at that sort of noise and the measurements, then how can we really, hang our hat on the decisions that we make with practitioners and with the coaches? So in order to really test that, I think it's important that we do the right sort of testing as well in order to actually, create that sort of measurement, that measurement error as such. So recently in football, for example, in soccer, I should say, there was this FIFA quality approach that came in. So FIFA do a number of quality programs in things like footballs and equipment, stuff like that. With the introduction of electronic devices in the sports, they then used, through partnership with Victoria University in Melbourne, a series of tests which basically companies could then put their device forward for testing to see where they're at. So just to highlight there on the screen, this was the actual testing program that they did. So they did testing in various places out in Australia. I believe they did a bit in the new camp as well. And you can see there effectively they've got quite a tight space in terms of on the pitch. They've got a 4-minute circuit highlighted from that figure in the bottom left there. They've got a couple of small-sided games and a couple of sort of linear sprints with a bit of outline of the pitch jogging as well. So quite a amount of varied type of stuff there. Some stuff that replicates the movement of football, change of direction, accel, decel, stuff like that. And essentially they were independent researchers who then collected this information and disseminated it to FIFA. So what we can see from this slide is this was some of the outputs that we got from the devices. So these are probably more the common devices that people tend to use by some of the key manufacturers. But what we can see here is basically the root mean squared difference value. So this is comparing it to the Vicon system, which is seen as the gold standard for any movement analysis. What we can see there for each of those devices is how that relates to the industry standard based on that score. And as you'll probably see, as we go across in terms of speed, so we start off quite slow, 0 to 7Ks, all the way up into our sort of high speed stuff. You can see that a lot of the devices, obviously the standards are pretty good in those lower speeds. Some of the devices, it does get worse as we increase that speed as well. And unfortunately, in the testing battery, where the points it says NA relate to the fact that the participants actually didn't get up to that speed in the testing. So, you know, even with this independent test, there's some limitations in terms of that protocol. But just to highlight that even you could classify these as 10 hertz devices, we're getting different outputs for the same variables effectively. So just a few thoughts then on GPS reliability and validity testing, just to kind of wrap up this first point really. So the first thing is make sure that you actually test in your own device. So as I've just shown on the previous slide, you know, I do a lot of reviews for papers and people often just put, well, it's a 10 hertz device, so that means it's sound for everything. It's very much, it's got to be that specific device, because if you open up a GPS device, you've got different components. You obviously got your inertial stuff, but in terms of the GPS chip, every device has got a different chip. It's also got different hardware, different firmware, stuff like that as well. So all of these different things play a part in the actual outputs from the device. It's also important as well to think about what data output methods that you typically use as well. So majority of practitioners I've worked with tend to just use what we call the software derived stuff. So the stuff where you get it from, you know, your Catapult, StatSport software, wherever, that's the actual output that you're going to use day to day. If you're a person who takes the raw data and puts it into a fancy R program or something like that, then that's what you need to test as well, because that's obviously what your output's going to be. And you also need to do it for each variable that you're looking at. So it's no good saying that your device is great for total distance if then you've not looked at accel, decel stuff, you've not looked at metabolic power, all that sort of thing. So very much being specific to your device there. The second point really is just have a look at the research papers. So, you know, there's a couple of decent reviews out now which have collated a lot of this sort of reliability and validity stuff. So hopefully somebody's already done this work for you, so you can have a look at the papers to see for your specific device and condition, you know, what are the values, what we're talking. If that data isn't available to you, then it might be a case where you might have to do some in-house testing as well. And that's where I think the link with universities can come in quite handy. So, you know, typically most unis now are pretty well kitted out with the likes of the Vicon system. Some people aren't really doing much with it either. They might do a bit of lab-based stuff. So my advice would just be to link in with your local university to then actually help to do that sort of in-house testing within your device and your players. The fourth point there is just relating to the actual comparison method that you're going to use. So again, a lot of studies might use things like timing gates to measure maximal speed. So okay, as a bit of a proxy measure, that might be okay for what you're after. But if we really want to establish the noise in the data, then we need to be using those gold standard approaches. So things like the Vicon system, or it might be, you know, a Stalker radar gun, something like that, which has that higher sampling frequency to look at. And the last point is just to make sure you actually replicate what you want to measure. So again, I see a lot of protocols where, like that other one, it might be like a bit of a circuit, but the total distance of that circuit's only, say, 140 meters. They might say, okay, the error is only 3-4%, so they're quite happy with that. But then if your players are covering 12K in a game with that sort of movements, you know, if you then, does that mean then you multiply that error by 10, 11 times? That actually might be the true error for what you're looking at. So for me, your protocol should replicate what you actually want to measure as well. So whether that's a match or whatever practice you're doing in training as well. So that's the first sort of boring stuff done. So, you know, reliability and validity is not exactly a sexy thing, but like I say, it's a very important first step you need to look at. The second point just relates to how we actually handle our GPS data and what we're looking at. So this paper we put together a couple of years ago now in IGSPP with some good authors on the paper. So This actually came about through a bit of a drunken conversation with Rick Lovell, who's on the top there, when we were over in America a few years ago. And at the time, we were both doing a lot of research, and I was working for Catapult at the time. And we quickly realized that there wasn't really anything in place in terms of industry standards for what we're looking at with GPS. So, there was a few papers at the time by the likes of Martin Boucher starting to come out, which start to pick holes in GPS to find that it wasn't as great as people thought. But there wasn't really anything on, sort of data quality or data control. So to balance the team out, we recruited a few Aussies, with Matt Varley and Aaron Coots as well. And we put together this review paper, which is free to download online. And we called it Black Box, really, because for me, that's what GPS was at the time. It was a bit of an unknown quantity. So in computer science, a black box is something where you've got an input and then you've got an output, but something in the middle that causes that, and it's a bit of an unknown sometimes. So this is what we try to achieve with this paper. It's more of a guide, really, for practitioners and researchers to think about how you actually handle of the data that we have. So rather than reading the boring paper, I thought I'd just summarize it with a few key points here. So the first thing is make sure you use the same GPS device across all the sessions, both training and matches, because what we found from numerous studies now is that there is a tendency towards a bit of inter-unit error in terms of that noise. So the newer units, so the GNSS stuff is a bit better than the older sort of GPS stuff, but rather than take that risk, we would always suggest that you use that same device and that's labeled up for that specific player. The second point relates to the actual data quality and making sure we check that. So when I spoke to the engineers at Catapult at the time and tried to figure some of this stuff out, these were some of the guidelines that they spoke about. So typically with GPS, you only need 4 satellites to get a connection of some sort. In order to get a strong or a decent connection, it's actually 6 or more is what we're looking at. A lot of the newer devices now, though, you'll typically find that you get at least sort of 12 to maybe 15 satellites connected at a time. So again, the device is a lot better now for that connection, but just to be aware that, that can be an issue. You've then got the likes of HDOF, which is less than 1, which is also something to look at. And also just checking your spikes in the data as well. Make sure it's worn in a tight-fitting garment, because some of the stuff by Chloe Cummins' group in rugby found that if you're wearing, a manufacturer's garment, that it can actually cause some issues there. So you get a lot of movement, particularly for the inertial sensor data as well. So make sure you use the manufacturer's garments. Just be aware of any firmware software updates. So if you do update your firmware on the device, or if a company brings out a new software update, again, from our studies that we've shown, this can actually change the same data output, both pre and post update. And something that Matt Farley showed you a bit more detail this morning was just make sure you keep your settings as consistent as possible. So things like your dwell time and your zone setting. So the third thing I want to talk about is just a bit on GPS data interpretation. So something I always found working with certain people was people often use just a number in order to use the GPS. So you might say something like, today should be a 6K day, or it should be a certain number of high-speed meters. The problem we get, though, is that obviously we're not training for numbers. We're training for physiological systems in the body, or we need to have a certain training outcome. So whether the focus is on something neuromuscular or something more skeletal, things like that, we need to think about the science and the physiology rather than just thinking about the number itself. There's a really nice review paper published a few years ago by Jos and his group, who used to be at John Moores with me. And he broke it down into 2 distinct areas. So one was more physiological and the other was biomechanical. So just to highlight briefly there, you can see with physiology stuff or physiological, we're looking more in terms of sort of speed zones and acceleration in terms of net power. That's obviously more our sort of respiratory cardiovascular stuff. Whereas our biomechanical load, which is something separate, is more about our sort of bone formation, tendons, ligaments, all that sort of stuff. And the way we actually quantify that might be different from what we look at in terms of the physiological stuff. So for me, this is quite a nice conceptual model of how you can actually break that down into different distinct physiological systems. Just to show you an example which we used in the paper. So this would be a typical microcycle in football. So if we think about, start from the previous game, we might have the first 48 hours, which focus on recovery. So with that in mind, we look at sort of limiting things like velocity, make sure it's low volume, low intensity. And the key variables to look at there might be things like max velocity, high speed distance, and also the duration or total distance for that session. As we move through the microcycle, we then have typically a 2-day period where we load the athlete up a little bit in season. So that again might be broken down into what we call intensive or extensive days, where the intensive is quite short space, so quite intense as the name suggests. And for that, we might look at things like accel, decel, net power. The extensive stuff where you've got a bigger space, that might be looking at things more like high speed distance or sprint distance as well. So you can see there we can start to differentiate it. And then as we lead into the next game where we've got a bit more of the match prep stuff, bit of a sort of 2-day taper as well, we might want to reduce the volume. So again, looking at total distance, but also calling to the work from Indigo Majika with tapering. We want to maintain a good amount of intensity. So you might look at meters per minute in terms of that relative intensity. And obviously then we've got the match. So we want to try and win. But in order to then monitor the athlete, we're going to look at obviously a whole host of things around volume, intensity, and movement. And just a minor point on this really is about combining, so not just looking at the physical and physiological, but actually integrating that into the tactical as well. So Jack Aid's done some really good work recently with his PhD, looking at in football, in soccer, how we combine the sort of GPS numbers and the movements and relate that to the tactical part as well. So in the example on the screen, he devised a few rehab drills for a wide midfielder where he's actually got the GPS numbers in terms of intensity and volume, but he's then related that into movement as well. So you can see for this particular drill, this then replicates the movement pattern, the actions of what's required for that player. So, you know, very important part is how much of that GPS stuff can we then incorporate in with the coaching philosophy and, you know, what coaching style do they actually have as well. And the last thing to finish on is just the translation into practice and into the key stakeholders. So for me, this is probably the hardest part and the most important part as well. My experience very early on and even recently, you tend to have a bit of a mixed dialogue with the key stakeholders. So typically it involved me saying something like this. So saying to the coach, you know, I've got this nice fancy report. I've created all these fancy pivots in Excel, blah, blah, blah. Have a look at it. The coach would then be a case of, well, thanks very much. You know, pop it down on the desk or I'll have a look at it later. And a lot of the time it just end up in here in the bin. So, you know, that's quite frustrating, but at the same time, a bit of a learning curve, because then you suddenly realize that printing off a report and put it on someone's desk doesn't imply that they took that information in and actually used it. This then led to, obviously, a few years later, well, quite a few years later, when Martin Bichet published this article in the Aspetar Journal. And I've read this multiple times now, and I still think it's one of the best pieces I've read in recent times. If you've not read it, it's, again, free to download with that reference there. And it's not a peer-reviewed journal, it's just an article, but very good in terms of actually breaking down in terms of, you know, that issue of how we actually get across to the key stakeholder. I actually then had a little look in terms of other things, in terms of feedback mechanisms. So one of the things I looked at was some of the stuff in business world. And I found this quite nice paper, quite a few years old now, so 2007 from Hattie. Well, they talk about feedback frameworks in business world. So if you look at some of the things on the screen there, so things like the timing of your feedback needs to be quick, prompt, and effective. The dialogue needs to be open. It needs to be in a format that's understandable for the key stakeholder. And the last point there about actually agreeing on action points. So, you know, although you're probably not going to take meeting minutes and send emails out to coaches, things like that, you know, having that sort of framework in place and applying that into sports, it just makes complete sense in terms of how we actually follow up with this type of information. And these were some of the key things that Martin highlighted on his paper. So the first one was just about building respect with the key stakeholders. So obviously that does take time. It's through things like having a coffee with them, sitting down for a meal, traveling on the team bus with them, getting to know them personally as well. So you're not going to have that when you go straight into a club. It does take a bit of time, but ultimately that's what you need to do. He also talks about going into the trenches, he calls it. So for that part, it's obviously when things are going great in the club, it's fantastic. Whatever you do is great. As soon as results start going against you, you know, everything turns to shit, doesn't it? And that's when you start to find out the true nature that people have. So coaches suddenly can turn nasty overnight. So you need to go into the trenches with them and actually then come up with the answers to those difficult questions. Third point, I think a few people have said today, but actually have a conversation. You know, sports scientists now, they're very much buried in the laptops and data and R and stuff like that. You know, use that information to then build a conversation and actually open some dialogue with the key stakeholder. Also understand the culture, the expectations. So, you know, if you're going into rugby where, you know, the players are used to sort of GPS numbers and physicality and stuff like that, they lift in the gym quite a lot, then that's a different culture than soccer where, you know, some of the players are like that. Half of them are just more about the banter and earning a decent paycheck. So again, understand the club you're at and also that culture of the sport. And the last thing, the key thing, which is something you can only really develop over time as well as is building that your personality really. So having a strong character, dealing with criticism, you know, keeping an open mind, but also showing humility as well. So you need to be able to challenge people and don't just be a yes man, but at the same time, you need to respect where that person's coming from. And just finishing off, so this was kind of the figure that we came up with the other authors on the paper. So we tried to make a bit of a flow diagram of how you can actually select the appropriate metrics to use within the GPS system. So firstly, we kind of looked at the reliability, validity. If it doesn't have that right amount, so if your CV percentage is through the roof, you know, you've compared it to your Vic on it, it's no good, then you probably seriously consider removing it from your practice. If it does have acceptable levels, then you also need to think about, is it linked to the right sporting demands, the movements? Can it also be interpreted easily by the key stakeholders? If not, then either remove it or work with those stakeholders to improve your feedback mechanisms. But hopefully by the end of that, you then come up with the answer, which is yes, we can use it to inform our practice. So the take-home messages then for me, first point is just to make sure you determine your signal and noise from your specific device, your sport as well, and also your athletes, because if you do a study on university students versus, you know, top end soccer players, then they're going to have completely different physiology and movements. The second point is just make sure you follow those recommended guidelines around how we handle data, and, you know, particularly practitioners, also researchers as well, make sure we're reporting on things like the data quality that we're getting. Third point is just obviously make sure we're not just using numbers for the sake of numbers and actually linking it to some sort of training outcome or physiology, or it also might be linked in with the tactics of the coach as well. And then finally, the soft skills approach. So actually building a bit of trust, make sure we get that buy-in over time and actually having a conversation with a human being. And that's me.